Once you have determined the end behavior of a polynomial function and discovered where it crosses the x-axis at the x-intercepts, then we can also determine the behavior of the graph at those x-intercepts. In 4.1.4, multiplicity is the key to understanding this behavior. If x minus k to the rth power is a repeated factor of p of x, then r is the multiplicity of the 0k. So if we have a factor that repeats r times, then we say r is the multiplicity. Let me give you an example. Back up here in example D, we had this factor x cubed that gave us a single 0. Well, if we look at x cubed actually represents 3 factors, x times x times x. Each of those factors would yield the same 0. So we say that the 0 has multiplicity 3. That means it repeats 3 times. And notice that is indicated by the exponent on that repeated factor. Observing if that multiplicity is even or odd predicts the behavior of the graph at the x-intercept. The graph crosses the x-axis at a 0 of odd multiplicity, and the graph bounces on the x-axis at a 0 of even multiplicity. So let's go back to the very first page of our notes and observe the behavior of the graph at the x-intercepts and determine if that represents even or odd multiplicity. So here's our graph. We're going to be examining just the x-intercepts. Remember, the zeros correspond to x-intercepts. Starting with our leftmost x-intercept. Notice the graph passes through that intercept and crosses the x-axis. So because the graph crosses the x-axis, that's going to be odd multiplicity. At the next example, the graph touches and turns, or we say it bounces on the x-axis. So that would be a 0 of even multiplicity. And the same thing is true here. The graph touches and turns or bounces, so it is also going to have even multiplicity. And at our last 0, since the graph crosses through the x-axis, we say that is a 0 of odd multiplicity. Now, using that concept, we can also determine the minimum degree of a polynomial just by looking at the graph. In example 3, it says, the graph of a polynomial function is shown. Using multiplicity, determine the minimum degree possible for the polynomial function and state the domain and range in interval notation. So to determine the degree of the polynomial, first we need to find the x-intercepts. This particular polynomial has 3 x-intercepts, so we know it is at least degree 3. However, looking at this x-intercept, the graph crosses the x-axis, so we know that must be odd multiplicity. The minimum odd number that we can think of is 1. So we know that the 0 here, -2, would have come from a factor with an exponent of at least 1. Looking at the next x-intercept at the origin 0, 0, we observe that the graph bounces. That indicates that 0 must have even multiplicity. So the smallest even number we can think of is 2. So that 0 came from a factor that repeats at least twice. And the last 0 over here on the right, we can observe the graph crosses. That indicates odd multiplicity. So the exponent on the factor from which that 0 came would be 1. At least 1, possibly 3, 5, or more, but we're looking at minimum possible degree. So if I sum those values, 1 plus 2 plus 1, I end up with a degree 4 polynomial. Now, from those zeros, we can also begin formulating the polynomial itself. The 0 here is -2, 0 here is 0, and the 0 there is 2. So if the 0 is -2, then it came from a factor x plus 2. I'm just going to write it down here below. If the 0 is 0, it came from the factor x minus 0, or just x. But in this case, it has to have even multiplicity, or an exponent of 2. The last 0 here is 2, so it must have come from a factor, x minus 2, with a minimum exponent of 1. So just by looking at the graph, we can begin to even formulate the equation of that function. Now, as is true for all polynomials, the domain of this polynomial is negative infinity to infinity, and the range goes from the lowest y value, which in this case is 4, up to infinity. Okay, we better practice that again because that's a lot of information. Looking at the next graph, it is definitely a polynomial because it's smooth and continuous. The activity occurs in the interior. The left end falls and the right end rises. So let's examine the x-intercepts. I'm just concerned about where the graph crosses the x-axis. So because we have 3 x-intercepts, the minimum degree at this point is 3, but we also have to consider multiplicity. Looking at the leftmost x-intercept, the graph bounces. Therefore, it must have even multiplicity. The minimum even number is 2. That's going to be true for the second x-intercept. The graph bounces there, indicating even multiplicity. Therefore, minimum multiplicity is 2. At the last x-intercept, we observe that the graph crosses, indicating odd multiplicity, or multiplicity of 1. If I sum those values, 2 plus 2 plus 1, we get a minimum degree of 5. Now, as we did on the previous example, let's begin formulating the function. This is not part of the problem, but it's really good to learn what multiplicity is. The first 0 here we looked at was negative 2. The factor from which it came then would be x plus 2, right? We're just working backwards. Normally we say if the factor is x plus 2, we set it equal to 0 and solve for x and get negative 2. Again, we're just working backwards. Now we're saying the 0 is negative 2. It must have come from the factor x plus 2. Now, because it bounces, it has even multiplicity. What does that mean? That means the exponent on that factor is at least 2. The second 0 here is 1. That means it came from the factor x minus 1. With a multiplicity of 2. And the last 0 here is 3. That would have come from the factor x minus 3. The exponent there is going to be 1 because our multiplicity is 1. So we're getting a lot of valuable information just by looking at the graph. The domain of this function is negative infinity to infinity. That's true for all polynomials. And notice there is no minimum or maximum y value, so the range is also negative infinity to infinity. Okay, on the next one, if you want to pause the video, see if you can determine the minimum degree, domain, and range, and then unpause the video and see if you get it right. So looking at our x-intercepts, we have 3 x-intercepts. The graph crosses at each x-intercept. So each x-intercept must have odd multiplicity. The minimum degree there would be 1. Remember, it could be higher, 3, 5, 7, but the minimum possible degree of each one of those x-intercepts is 1. Therefore, the minimum degree of the polynomial is 3. Did you work on the definition of the function? This could look like x minus 2 times x minus 1 times x minus 3. That's the fundamentals of the function. It may have a leading coefficient. Again, we're just looking at what are the factors of that polynomial. The domain is negative infinity to infinity, and the range is also negative infinity to infinity. In the next video, we will put all of this together and start graphing polynomials.